Hello and welcome back to the Tech Blackboard. Today in part 8 of DP203 exam question and answer series, we are going to cover 15 very exciting and latest questions on DP203. And today we will be focusing on questions related to Azure Synapse Analytics, Azure Databricks and Azure Event Hubs. Important concepts are coming up, so please pay attention, watch the video very carefully and get one step closer to your DP203 exam certificate. In case you are new here today or you happen to miss any of our previous parts, it's worth mentioning that so far in previous 7 parts, we have already covered 80 important questions on DP203. All the previous videos covered important concepts and I also shared the detailed explanation on each of the question and also provided right Microsoft documentation for further self-learning. Highly recommend to watch all the previous parts for full course coverage. The links for all the videos are available in the description box. Besides understanding the concepts through videos, we also understand the value of self-learning. Thus, to help you do self-study and revise the questions in offline mode, I will share a free PDF file containing all the 15 questions with answers covered in this part 8. And for that, you have to tell me the correct answers for the question number 87, question number 93 and question number 100. Answers to these 3 questions are coming up in this very video itself. And friends, at any stage, if you find this video worthy of your time and an increment in your learning, please appreciate our efforts by pressing the like button, subscribing to the channel and press that bell icon to receive all the notification for our upcoming videos. So let's begin part 8 with a set of 3 questions on Azure Databricks. Here comes question number 86. The question says that you plan to create an Azure Databricks workspace that has a tiered structure. The workspace will contain the following 3 workloads. The first one is a workload for data engineers who will use Python and SQL. The second one is a workload for jobs that will run notebooks that use Python, Spark, Scala and SQL. The third one is a workload that the data scientists will use to perform ad hoc analysis in Scala and R. Further, the question says the enterprise architecture team identifies the following standards for Databricks environments. The first one is the data engineers must share a cluster. The second one is the job cluster will be managed by using a request process whereby data scientists and data engineers provide packaged notebooks for deployment to the cluster. Third one is all the data scientists must be assigned their own cluster that terminates automatically after 120 minutes of inactivity. Currently, there are 3 data scientists. You need to create a Databricks cluster for the workload. The solution given here is that you create a high concurrency cluster for each data scientist, a high concurrency cluster for the data engineers, and finally you create a standard cluster for the jobs. Does this meet the goal? And you have to tell whether it's a correct or incorrect solution. The correct answer for this question is no. And stay with me, I will provide the correct logic of this question in question number 88 as this question has 2 more variations. So let's check them out. And now we see one more variation of the same question. This is question number 87. In this question, however, the solution is little different. This time the solution says that you create a standard cluster for each data scientist, a high concurrency cluster for the data engineers, and finally you create a high concurrency cluster for the jobs. Does this meet the goal? And this time as well, my friends, the answer is no. So what is the correct answer? Let's check out in question number 88. So here comes question number 88 and this time we have solution which says that you create a standard cluster for each data scientist, a high concurrency cluster for the data engineers and a standard cluster for the jobs. Does this meet the goal? This time the answer is yes. This solution will fulfill this business case. Looking at the logic why this solution is correct, you see there is no need for high concurrency cluster for each data scientist. Standard clusters are recommended for a single user. Standard clusters can run the workloads developed in any language, Python, R, Scala, or SQL. And that's exactly what our question also mentioned, that we have to develop workloads that are created in languages like Python, R, Scala, and SQL. And then a high concurrency cluster is managed cloud resource. The key benefit of high concurrency clusters are that they provide Apache Spark native, fine-grained sharing for maximum resource utilization and minimum query latencies. So that was the quick logic on choosing yes this time for this solution. Now let's move on to question number 89. This is a true-false kind of question. The question says that if an event hub goes offline before a consumer group can process the events it holds, those events will be lost. You have to tell whether this statement is true or false. The correct answer for this statement is it's a false statement. And the reason for same is that events are persistent. So keep in mind that events are persistent, which means that each consumer group has its own cursor maintaining its position within the partition. The consumer groups can resume processing at their cursor position when the event hub is available again. So that means that whenever you are using events, you can be rest assured that nothing will be lost even if the event hub goes offline. And that's the beauty of using event hubs. Now let's move on with question number 90. The question says that you are a data engineer for Contoso. You want to view the key health metrics of your Stream Analytics jobs. Which tool in Stream Analytics should you use? Your options are dashboards, alerts, or diagnostics. The correct answer for this question is dashboards. Now let's check out the quick explanation. So dashboards are used to view the key health metrics of your Stream Analytics jobs. As we see, this is the correct option. Then we have alerts. So alerts enable proactive detection of issues in Stream Analytics. However, for this question, we need to view the key health metrics and we are not into proactive detection. Then we have diagnostics. So diagnostics logging is turned off by default and can help with root cause analysis in production deployments. So that's the quick explanation for each of the option. Coming up now is question number 91. The question says that you are designing a real-time dashboard solution that will visualize streaming data from remote sensors that connect to the internet. The streaming data must be aggregated to show the average value of each 10-second interval, and the data will be discarded after being displayed in the dashboard. The solution will use Azure Stream Analytics and must meet the following requirement. The first one is minimize latency from an Azure Event Hub to the dashboard. The second one is minimize the required storage. The third one is minimize the development effort. What should you include in the solution? And here you can see you have to answer this question on 3 levels. The first one is Azure Stream Analytics input type, and then you have to tell what will be the Azure Stream Analytics output type. The third thing that you have to answer is what would be the aggregation query location. Looking at the answer for the Azure Stream Analytics input type, and that is Azure Event Hub. And then we have the output type. For the output type, the correct answer is Azure Power BI. And then for the aggregation query location, the correct answer is Azure Stream Analytics. A great place to learn about Stream Analytics and Power BI is this Microsoft documentation. And here you can experience how to build a real-time analytics dashboard for streaming data. All the information is given. You can also read about Microsoft Power BI. And then if you follow this document, you will know what are the prerequisites. Then after that, it's given how to add Power BI output, and much more information is given in the documentation. And as I said, this is a great place to learn Stream Analytics and Power BI. Now let's move on with question number 92. And it says that publishers can use either HTTPS or AMQP. AMQP opens a socket and can send multiple messages over that socket. How many default partitions are available? The options given are 1, 2, 4, 8 or 12. And the correct answer for this question is option C. So we have 4 default partitions that are available. So by default, we have 4 partitions available. Partitions are actually a bucket within the Event Hub. Each publication will go into only one partition. However, each consumer group may read from one or more than one partition. And now we have question number 93. The question says that you are designing an enterprise data warehouse in Azure Synapse Analytics that will contain a table named customers. Now customers will contain credit card information. You need to recommend a solution to provide salespeople with ability to view all the entries in customer table, and then the solution must prevent all the salespeople from viewing or inferring the credit card information. What should you include in the recommendation? Your options are data masking, always encrypted, and then we have column level security, and the last one given is row level security. The correct answer for this question is that we should go for column level security. Now friends, if you remember in question number 21 of part 3, we had a similar question. In that question, we choose data masking, but here we are choosing column level security. And the reason is that in question number 21, we were to hide some part of the phone number, but here we want to enable to the salespeople to view all the entries of entire customer table. But there is an important catch here. We also want to restrict them from viewing the credit card number. So basically, we are looking for the column level control. Once again, we want to enable salespeople to view the entire customer table. However, we want to restrict them from viewing the credit card information. So one column of customer table needs to be restricted. And in case you want to read more on column level security, this is the Microsoft documentation. It says that column level security allows customers to control access to table columns based on the user's execution context or group membership. Here a wonderful video is given by Microsoft. You can watch this video. And then move along on this documentation. Here you can also understand what are the different syntax. And then to further strengthen your learning, Microsoft has also given a good example. So a good documentation to refer in case you want to learn more on column level security. Moving on with question number 94. It's a very interesting question. Let's read it out. The question says that you implement an Azure Enterprise Data Warehouse in Azure Synapse Analytics. You have a large fact table that is 10 terabytes in size. Incoming queries use primary key, sales key column to retrieve the data as displayed in the following table. So two things you can note upfront here. The first one is that the fact table is big. It's 10 terabyte in size. And the second thing is that the incoming queries are using the primary key. And what is the primary key? Primary key column is sales key. Moving on with the table, it starts with the primary key, which is sales key. Then we have city key, customer key, stock item key, invoice date key. We are also given with quantity, unit price, and total excluding tax. And then the question says that you need to distribute the large fact table across multiple nodes to optimize performance of the table. Which technology should you use? Your options are hash distributed table with clustered index, or should you use hash distributed table with clustered column store index? The third option is round robin distributed table with clustered index. And then in the last, we are given with round robin distributed table with clustered column store index. The correct answer for this question is option B, hash distributed table with clustered column store index. So basically, hash distributed tables improve query performance on large fact table, and column store indexes can achieve up to 100x better performance on analytics and data warehousing workloads, and up to 10x better data compression than traditional row store indexes. And in case you want to read more on column store indexes and how you can use to improve the query performance, this is the Microsoft documentation. Here you can read all the recommendation for improving the query performance. They have listed out all the recommendation one by one, so you can read the documentation in more detail. Coming back to the presentation, here I just wanted to add that friends, the options C and D, which are talking about round robin distributed tables. So basically round robin distributed tables are useful for improving loading speed. And now let's move on with question number 95. The question says that you have an enterprise data warehouse in Azure Synapse Analytics. Using PolyBase, you create an external table named ext items to query paraquet files stored in Azure Data Lake Storage Gen 2 without importing the data to data warehouse. The external table has 3 columns and you discover that the paraquet files have 4th column named item ID. Which command should you run to add item ID column to the external table? I hope you understood the requirement. The requirement is that you already have an external table which is named as ext item. This table has 3 columns and now you have to add a 4th column which is item ID to this existing table. So which command do you think will fulfill this job? Options are given here. The first 2 commands are alter commands. You can see first one, option A, is alter external table and the second one is alter table. And then we have this big command which says that first you drop the external table and then you create the external table with the old columns and the new column as well. Or should you go for this command which gives you drop external table format paraquet file 1 and then you create using this command? The correct answer for this question is command C. And as I just mentioned, first you have to drop the external table and then you have to create the external table with the new column as well as the existing columns. Now let's move on with question number 96. The question says that you build a data warehouse in Azure Synapse Analytics dedicated SQL pool. Analysts write a complex select query that contains multiple joins and case statements to transform the data for use in inventory reports. And then the question says the inventory reports will use the data and additional where parameters depending on the report. The reports will be produced once daily. You need to implement a solution to make datasets available for the reports. The solution must minimize the query times. What should you implement? Your options are an ordered clustered column store index, a materialized view, a result set caching, or should you implement a replicated table? The correct answer for this question is a materialized view. Friends, materialized views are very important concept. Let's understand using Microsoft documentation. So this is the Microsoft documentation that gives you more insights on performance tune with materialized views. It says that materialized views for dedicated SQL pool in Azure Synapse provide a low maintenance method for complex analytical queries to get fast performance without any query change. And this article discusses the general guidance on using materialized view. You can also read a comparison between materialized view and standard views. Both materialized view and standard views are very important concept. The link for this documentation is available in the description box. In fact, links to all the documentation referred in this video are available in the description box. Now let's move on with question number 97 that says that you are designing a partition strategy for a fact table in Azure Synapse Analytics dedicated SQL pool. The table has following specification. The first one is contains sales data for 20,000 products. The second one is use hash distribution on a column named product ID. The third one is contain 2.4 billion records for the years 2021 and 2022. Further, the question says which number of partition ranges provide optimal compression and performance for the clustered column store index. Is it 40, 240, 400 or 2400? And the correct answer for this question is option A, 40. Now let me introduce the rule for calculating the partition. So the rule is the number of records. How many records we have? We have 2.4 billion records. Then it says divided by 1 million multiplied by 60. That gives us 60 million. So basically we have divided number of records with 60 billion. We have 2.4 billion records divided by 60 million and that gives us 40, which is the accurate partition range. And with that, let's move on with question number 98, which says that you are designing an Azure Synapse Analytics dedicated SQL pool. You need to ensure that you can use audit access to personally identifiable information or PII. What should you include in the solution? Your options are column level security, or should you use dynamic data masking, or row level security, or sensitivity classification? The correct answer to this question is option D, sensitivity classification. And friends, if you are working on a system that uses personally identifiable information or it comes under the umbrella of GDPR, then please read the Microsoft documentation before you design any solution. And friends, how many of you know the difference between personally identifiable information and GDPR? Do let me know in the comment section what you think both are and how you handle each one of them. Moving on with question number 99, it says that you are designing a security model for an Azure Synapse Analytics dedicated SQL pool that will support multiple companies. You need to ensure that the users from each company can view only the data for their respective company. Which two objects should you include in the solution? Each correct answer presents the part of solution, and please note that each correct selection is worth 1 point. Your options are a security policy, a custom role-based access control or RBAC. Then we have a function. The fourth option given is a column encryption key, and then we have asymmetric keys. The correct answer to this question is option A and option B. And that brings us to the question number 100, which is the last question for part 8 on DP203 exam Q&A series. Let's read the question. The question says that you have an Azure Synapse Analytics job that uses Scala. You need to view the status of the job. What should you do? Your options are: from Synapse Studio, select the workspace. From Monitor, select SQL request. The second option is: from Azure Monitor, run a custom query against the Azure Diagnostics table. The third option is: from Synapse Studio, select workspace. From Monitor, select Apache Spark application. And the fourth option is: from Azure Monitor, run a custom query against the Spark logging event _CL table. And the correct answer for this question is option C. And in this option, from the Synapse Studio, you have to select the workspace, and from the Monitor, you have to select Apache Spark application. And let's not forget the Microsoft documentation on how to use Synapse Studio to monitor your Apache Spark application. Everything that you need to know around this concept is available in this documentation. I hope you enjoyed today's session with 15 questions on important concepts like Azure Synapse, Azure Databricks, and Azure Event Hub. Friends, I look forward for your support on the efforts that we spend, so please do not miss to press the like button and subscribe to the channel. Also help us reach other audiences, so please do share our videos. You can connect us on other social media platforms like Instagram, Facebook, and Twitter. Information for the same is now flashing on your screen and also available in the description box. Thanks for being with us. I will see you in the next video. Till then, stay fit, keep learning, and thanks for watching.
If this video has added any value in your learning, a like and subscribe is highly appreciated. Share this video in your family and friends to spread and expand their learning. Your comments and feedback give me a chance to interact with you, and I look forward for them. We will meet again in our next video. Till then, stay fit, keep learning, and thanks for watching.